Hi, and welcome to Chapter 14. In Chapter 14, we are going to cover remote access and long-distance communication concepts. We're going to cover some transmission options and a couple of other things that need to go with remote desktop and connecting from one location to the other. Let's get started. So looking at our roadmap, you can see that we're about 3/4 of the way through with the course. We're finishing up remote access in this chapter, and the next chapter for Chapter 15, we're going to start on administration, which starts with a very long chapter on network security. So that's a really important chapter. This chapter on remote access should be a lot of review concepts, as we've covered a lot of these protocols and choices in the past. So let's start with a little bit about the telecommunication system. And yes, some of these concepts we've already introduced to you. So hopefully they're starting to kind of feel like you've learned them before and maybe settling in a little bit better. First off, a local exchange carrier, or LEC, is your local central office. So when you think about your telecommunication system, if you have your local phone company, whatever that happens to be, that's going to be your local central office. Now, the local central office is going to have phone lines that are going to be sent out from the central office to your home or your office. In this case, we call that the point of presence. And the local loop is the line that runs from the central office to that point of presence. Point of presence is where it goes onto your property, and it goes from the telephone company's line into your personal line, the one that's at your house. So that moment there, suddenly the telecommunication system or the local company is going to cover up to that point, but any wiring in your home, that's on you. That's going to be your responsibility, or the owner's responsibility. So we call that transition point from where it was the responsibility of the central office to the homeowners association, or the homeowners responsibility. That's the point of presence. The distance between those two is called the local loop, the section between the home office and your home, or the central office and your home. In between individual local central offices, we created a trunk line, which is a series of hundreds of pairs of twisted pair or fiber that goes between central offices. So it does that line in between the two, kind of the freeway between two central offices, where each central office goes out to its customers' premises through a local loop. When we talk about our telecommunication system, we have the head end, which is that local distribution point. Where is the point that the communication is going through till? So in that point where it starts to distribute to multiple locations, that's going to be called the head end, where all of those homes all connect to a single point. Obviously, we have a little bit different for businesses. Businesses tend to use a T1 line, and we'll talk about TCarrier lines in just a second. So if you have a home office or a small office, you may have a regular local loop going there. But if you need to have a dedicated line, you can go ahead and have a T1 line that is run straight from your corporation or your company offices to the local central office, and it's dedicated specifically for you. We also usually put a T1 line in between the central offices and your ISP, or your internet service provider. Because so much traffic goes through that line, we can make it a trunk line using a TCarrier line, and that uses the T1 lines. So generally when we refer to the communication company, we call them carriers or providers. Common carriers are things that do a service for the company, or for the public at large. So a common carrier would be something that provides electricity or septic or sewer or phone lines. They're common carriers because they provide for the entire common good. At this point, I'm going to start breaking down the different types of networks and the different types of connections that you can have. Each of the next 4 slides or so is going to have 2 different types of connections with different pieces of information on them. You need to know all of these, so you need to know the difference between them. So the first is the original public switched telephone network, which is sometimes called the plain old telephone service, POTS, POTS. But most of the time these days we refer to it as the public switched telephone network. This started with the switchboards and now is just what we think of whenever you have a regular phone line connected into your house. A lot of people don't even have hard lines anymore, but that's what this refers to. They're always an analog, and they go across the analog cables to get to the central office and to move on from there. We also have the option of ISDN, which is Integrated Services Digital Network, ISDN. And ISDN lines are fully digital. They are no longer analog like they were in the old days with public switch telephone systems. So the fully digital lines. There are 3 different types of ISDNs. You can have your basic rate ISDN, your primary rate ISDN, or your broadband ISDN. The difference between these, when we think about the plain old telephone system, when you use regular dial-up back in the olden days where you had a modem and it made that funny sound and your mother couldn't pick up the phone while the phone was connected. With those, they were analog, and they ran at about a speed of 56 kilobits per second at their max. That was the fastest they would ever go. With digital, when you got into ISDNs, you had a couple of different options. So the basic rate ISDN, or the BRI ISDN, is designed with 2 B channels and 1 D channel. So let me explain channels. B channels, or bearer channels, are designed to carry the data or the voice or the video or a combination therein. Each B channel can hold 64 kilobits per second each. A regular basic rate ISDN has 2 B channels, so they can go up to 128. So their longest speed is 128. That third channel, the D channel, only holds about 16 kilobits per second, and it's used for transmission, setup, essentially controls, being able to handle control signals that go between setting up the transmission connection, closing it back down. So the 16 kilobits per second that are available in a D channel aren't really useful because you're not going to be sending data across there. That's just used to control the connection. So the important thing, basic rate ISDN, ISDN, has 2 B channels, each B channel 64 kilobits for a total of 128. The primary rate ISDN has 23 B channels, and 1 D channel. So it has a total of 24 channels. 23 B channels and 1 D channel. They only need 1 to do the connection, to handle the setup and things like that, and it's still at its 16. But those 23 B channels get us up to a full data rate of 1.5 megabits per second. 1.544 to be specific, but 1.5 megabits per second because you have 23 of those channels, each of them going along at 64 kilobits per second. So now we can get up to 1.5 millibits per second for the primary rate. These are the 2 basic ISDNs using the B and the D channels. The third is our broadband ISDN, which is just notated as B ISDN, as opposed to basic rate, which is BRI. BRI, basic rate ISDN, because we like to use acronyms. So broadband ISDN actually allows you to send multiple frequencies as opposed to regular ISDN, which can only send a single frequency. So multiple frequencies in a broadband, the way broadband works with multiple frequencies, and it can go up to about that 1.5 megabits per second as well. So both the primary rate and the broadband both go up to that 1.5 megabits per second, but the primary rate has to send a single frequency where the broadband can send multiple frequencies. So these are our options with ISDN. Next, we're going to talk about our cable internet versus our DSL. So cable internet was provided by the cable television systems. At the time that cable came out, most people had cable television, where you would connect through the cable system to get your television cable. And they were able to piggyback data on top of the cable television system lines. Usually they would use what's called a cable modem. So it's a modem designed to convert from your cable operator using a regular RJ45 or CAT cable, or sometimes a USB. It depends on the connection that you would want to have. Cable systems were generally asymmetrical. Your uplink and downlink speeds were different. So usually you had a really good downlink, but your uplink was kind of slower. And you would make sure that you came into your house and then ran a splitter. And the splitter was designed specifically to allow you to split that phone cable or the cable coming in into the cable TV going off one direction and data going off the other. The data would go through the cable modem and get over to your computer, whereas the cable or your television would go through the cable TV converter and over to your television. So the splitter was able to do that. When we do the local distribution area, known as that head end, we talked about the head end being able to have that inside your distribution area. In our cable, we have the bandwidth, and the bandwidth is going to fluctuate depending on how many users are online at a time. That was the thing about cable internet. It depended on the actual demand. So if you had a large number of users on at the same time, you probably had slower internet. Whereas if you did this at 2 or 3 in the morning, everybody's offline, nobody's using it, you might have much faster speeds. The other option in this situation was the DSL, or the digital subscriber line. These were designed to allow high-speed internet using your local loop phone lines. Remember, the local loop phone lines using a regular dial-up could only go as high as 56 kilobits per second. DSL increased that significantly. So you were suddenly able to get into the megabits sides. And the list here is of how fast you could go for either your upstream or your downstream when you were using DSL. And DSL uses modulation to allow multiple channels to carry more data. Each of those channels could carry data, which allowed it to go faster in general than your regular phone systems, your regular public switch telephone network. The problem with DSL was that the distance was somewhat limited. So you can see the distances here between your modem and the central office. The minimum was 1,000 feet, which is not very far. And it would go up to about 18,000 feet for asymmetrical DSL. Each of the different types of DSL, which have been explained to you in another chapter, has different distance requirements, but they all kind of have that download speed of up to 1.5, except for, of course, your very high bit rate, which got up into the 13 to 52 megabits per second. So you could get some really good data speeds with your VSDL, but you're limited on distance. So the distance from your home or from your cable modem to the central office was the important conversation. A little side note on this, generally with analog signals, we were able to use something called a loading coil. And a loading coil would amplify those signals. It doesn't work with DSL because you can't amplify digital signals the same way you can amplify analog signals. So loading coils can't be used to make that distance go longer. The next two that we're going to talk about is our satellite and our TCarriers. So satellites, as we've discussed before, can also be used for internet or data communication. Typically, their download speeds are between 400 and 500 kilobits per second, but business satellites can go up to that 1.5 megabits per second, same as your DSL. If you're going to do uplink, they require a radio transmitter, which makes sense. It's a satellite. We call those an up converter, and that's a term you're going to want to try to remember. That up converter is the uplink transmitter that allows you to transmit data up to the satellite rather than just pulling it down. Problem with satellites, of course, was you had problems with line of sight, you had problems with weather, and of course you had problems with sunspots. So things like this, anything inclement weather or line of sight issues, trees, hills, anything in the middle, is going to cause a problem with your satellite. With your TCarrier, so these are your T1 lines or T2 lines, these are your leased lines. So it's a specific dedicated line from location to location. So from a single location straight to the central office. TCarrier lines are different in speed and in cost. Obviously a T1 line is cheaper than a T2 line. And the number of T1 lines with a T1 versus a T2 is different. So we kind of go up exponentially in this significant speed of T1 is a single line, T2 would be 4 lines, T3 would be 28 lines, and with each individual line, you get more channels. You get 24 channels per line. So when you're up to 168 T1 lines, you're looking at 4,000 channels or a maximum speed of 274,000 megabits or 274 gigabits per second. So a T4 line going really fast. Really important thing with T1 lines. they're going to use a multiplexer and then this channel service unit, data service unit concept to be able to get those channels together, get the data together, and organize everything. In other countries, everything we've talked about as far as T1 lines are United States specific. So when you go into Europe or you go into Japan, you have different versions of a T-carrier laced line. Fun thing to remember. So the USA lines are T's. They're T-carriers. So T1, T2, T3, and T4. And we go up to T4. In Europe, we call them E's. E1, E2. And you can see they go up to E5, which is faster than our fastest speed. In Japan, we call them J lines. J1, J2, J3. And those also have speeds that are a little bit faster than the United States speeds when they get up to their maximum speed. So they all kind of start at that 1.5 for their first level, and then everything increases from then on. The Network Plus exam emphasizes this concept that it's not all about America. So it's not all about just the T-carrier lines, but you really want to know what those European and Japanese counterparts are as well. If not memorizing the actual speed for each of them, recognizing that they do go from 1 to 5, they're E lines or J lines, and which country they would go with. So that's a little extra thing just for the test to remember. If you're only going to be working in the United States, you wouldn't need to know that too significantly, but more knowledge is never a bad thing. At this point, we talk about our fiber networks, fiber interfaces. So we've talked about FDDI, our fiber distributed data interface. It's done in a dual ring with fiber optic. Fiber is great, FDDI, because it has this great high reliability because it's in this dual ring topography, and it has really high bandwidth. The great thing with FDDI is that you can actually get distances of up to 62 miles, which is huge. It's a huge distance when you think that we were just talking about 18,000 feet. 62 miles is a little bit longer than that. So FDDI is great for long distances. And again, high reliability, high bandwidth. Synchronous optical network, or SONNET, is similar to your T-carrier, but instead of using your twisted pair, it uses fiber. Has a higher bandwidth because it uses fiber and uses its own levels to describe its speed, similar to your T-carrier levels. So similar to your T1, T2, T3, T4, in this case, we have OC values. So OC1, OC3, OC12, 24, 48, 192. And each of them refer to a specific maximum data. So at 50-ish megabits per second, you're looking at OC3 being 145, OC12 being 600-ish, somewhere in that vicinity. It's based on the number of megabits and the different types of levels. But you can see how those speeds increase as we go along down the levels for SONNET. Our last two types of connections are our X25, which does our packet switching using analog, and our frame relay, which uses packet switching using digital. So using analog with an X25, again, you're at that 56 kilobits per second. They just can't get much faster than that when you go with an analog technology. The International Telecommunication Union, or the ITU, is the standard for X25 that we use, and it's the one that controls all of the standards for packet switching using analog. Remember, packet switching as opposed to circuit switching. Packet switching where we send out multiple packets and then they all end up wherever they're supposed to go. X25 is not used as much anymore because obviously frame relay was faster and it uses digital. So these two are kind of like the original X25, and then we moved on to frame relay. Frame relay uses a permanent virtual circuit to do packet switching. So it sets up this cloud situation where we can send things into the frame relay and send them around through the cloud to get to wherever they need to go. They use, for frame relay, we actually use a shared lease line. So it's cheaper than your T-carrier lines, your T1 line. So a frame relay is going to be cheaper because we can share the resources and therefore share the costs. Bandwidth on this, similar to cable, is going to fluctuate based on usage. So depending on how many people are on your frame relay system is going to depend on your available bandwidth, either from 56 kilobits per second, the slowest that it could possibly be, up to 45 megabits if nobody else is on the line. So that changes based on how many other people are on your network. So this list is in the book. I'm not going to go through and repeat everything I just said. There's a couple in here that we didn't cover. So ATM, which we talked about in the last chapter, and the different DSL options are in here, your FDDI, your T1 lines, so on and so forth. This is a good chart to reference, especially when it comes to the different data rate options and what type of access. Are we going to do a dial-up? Are we going to do virtual? Or are we going to do a direct connection? So our different options for access, and then of course it gives you some more details as far as what the different technology options are and how they're used. Moving into our dial-up networking section. So dial-up networking doesn't always mean specifically that you are dialing in on your plain old telephone system. You may be using ISDN or X25, but you are dialing in from somewhere. Network systems in which dial-up connections used are going to access a remote access server from a remote access client. You must have a modem installed on your client so that you can connect in to dial-up. When you do your dial-up, it's accessed remotely by users who are not currently on the LAN. So if you're currently on the LAN, you're not using a remote access server. Remote access server is designed specifically to handle the people who log in. So in this image here, you can see we have our database server and our office PC and our printer and our mail server. If you are inside your LAN, you are not dealing with the remote access server at all. If you are outside your LAN, so you're over at your house, you need a client on your local machine. You're going to dial in through your phone lines and connect into your remote access server. So that's how this one's going to connect. You don't always have to use your plain or your packets or your switching telephone network. You're going to be using either your ISDN or X25, but it's still going to be slower. We have 3 different types of service that are available to your remote access server. We can dial in only, dial out only, or do full service. So dial in only means that you can call in, but the host sitting there on the remote access server cannot do anything out to the network. They cannot make any calls out. They cannot access outside of the LAN. You can get in, you can get your data, but it can't change anything on the outside world. Dial out only prevents anyone from calling in, but it does allow the remote access server to call out, so it can dial out. A full service allows both. The way that we connect to this is through the Remote Desktop Protocol, or RDP. Usually a Windows computer, but anything with an RDP software, can use a piece of software client to communicate directly to your remote access server. Uses TCP/IP and uses terminal service technologies to be able to do that. So you can imagine that we have our terminal server and we have our terminal client. The client is going to send keyboard and mouse commands across, and the display from the server is going to come back to the client. So you send some information, it responds. You send some more information and it responds. What you are sending is keyboard and mouse strokes, and the display is coming back to tell you what it's looking at. This is your basic RDP for your remote desktop protocol. All right, there are a lot of different protocols that go along with remote access. It's a little hard to remember all of these, but these are acronyms I'd like you to try to remember, at least to try to remember what they stand for. And that should help you if it comes up, what does this acronym stand for and why is this different than the other one? If you can remember what the protocol names are, what the actual words are for the letters, that's going to help you. So we're going to start at the top with SLIP. So Serial Line Internet Protocol is an asynchronous protocol using Internet Protocol, so IP. So Serial Line Internet Protocol, it's an IP protocol. Serial line, meaning that it's going to go through the phone line. It's going to use serial ports to go in through your phone line. Our point-to-point protocol, or PPP, is synchronous, but it uses IPX and AppleTalk. It also goes through your phone line. So instead of using IP, it uses IPX and AppleTalk to do them, doing a point-to-point connection. It is synchronous as opposed to asynchronous. So the first two, one's asynchronous, the second is synchronous. PPTP is point-to-point protocol with the word tunneling thrown in the middle. Tunneling is going to refer to the encapsulation of the existing protocols. So it's an enhanced version of PPP that is going to allow tunneling to make sure that we don't have to use IPX or AppleTalk. We can tunnel it or encapsulate it inside of your IP protocols or any other existing protocols at that point. Our PPP OE, over Ethernet, is our point-to-point. So we're back to our PPP. It's our point-to-point, but in this case it goes over the Ethernet as opposed to going through your phone line. and it has multiple clients. So you can have multiple clients that use your PPEoE. So going over your Ethernet as opposed to going over your phone line. The first three all went over your phone line. Your multi-link point-to-point, MLPPP. So PPP, point-to-point protocol, point-to-point protocol. Try to get that one through your head. Point-to-point protocol with multi-link in the front. Multi-link, multi being multiple, link being links. There are 2+ links that increase your bandwidth. Because there's multiple links going through, it's kind of like having multiple fire hoses all shooting at the same thing. We're allowed to have an increased bandwidth because we're using multiple links. This can also go through your phone line using the ISDN, the telephone network, or your X25. So these are going to go through an analog connection over there. With your BAP, this is a bandwidth allocation protocol, and it actually allows the number of lines in your MLPPP to change on demand. So imagine you really only need 1 or 2 lines most of the time, but sometimes right before a big order goes through or something important happens, you might need to increase that to 6 lines. Your BAP, your bandwidth allocation protocol, is going to be able to dynamically increase the number of lines on demand. So as you need more, it'll add more lines to your MLPPP. Your layer 2 forwarding is not exactly a protocol, but it is part of the protocols that you need to remember. Layer 2 forwarding, remember we're in layer 2 down on the data link. Because we're forwarding at the data link level, there is more security, and usually it uses a virtual private network or a VPN. So L2 forwarding. L2 forwarding got kind of replaced by L2 TP, which T being tunneling, P usually means protocol. So layer 2 tunneling protocol. So first we started with layer 2 forwarding to add a little bit of extra security. And then in layer 2 tunneling protocol, we actually combined our PPTP, remember our tunneling protocol from the other side, our point-to-point tunneling protocol. We combined our point-to-point tunneling protocol with our layer 2 forwarding. So we got the security from layer 2 forwarding with our tunneling protocol from point-to-point. And we created layer 2 tunneling protocol. Okay, if you're still with me, 2 more. The multi-protocol labeling switching. This isn't, again, not really a protocol. It is, but it doesn't end in the word protocol, so it throws everybody off. What it does with multi-protocol label switching is it allows you to add a label to the packet, actually at the packet level. It uses edge routers to define the router that exists at the beginning or at the end of a LAN so that you can control some security there. But it uses both your data link layer and the layer above it, layer 3, to be able to control the packet. Remember, making the packet, organizing the packet, putting the different information into the packet. So our MPLS, multi-protocol label switching, is going to allow your router to be able to switch based on this label we've given. Imagine putting a big UPS label across the top that says this goes to that location. Because we can label switch, we can put a label on there that says this is where the destination is, and it allows things to go to where they're supposed to go faster and more secure. Don't send it anywhere else except where I want it to go. The last one, of course, is our voice over internet, which we beat to death in a previous chapter, so we're definitely not going to fight this too much. At this point, we simply talk about the session initiation protocol trunk line that can provide the voice over IP and streaming media to customers with that session initiation protocol based private branch exchange, or PBX. So if you have a PBX that's session initiation based, then you can use an SIP trunk protocol to use that with your voice over IP. Couple of different protocols. Try to remember what the letters stand for so that you can remember why PPP versus PPTP is the difference between point-to-point and point-to-point tunneling. Once you know it's tunneling generally refers to encapsulation. We can go through those different options. All right. With a VPN, not a whole lot to say about a VPN. We've already talked about it before, but remember, a VPN is your simulated and independent network created by software, usually over a public network. The software packages usually handle the security, the handshake, the connections, making sure that the authentication works correctly. Transport in a VPN is encapsulated into the protocols. So generally we would use either the PPTP, the L2F, or the L2TP, although all three of those are older and not as common as the current IP security or IPsec. IPsec is currently the most common VPN security used today. It can choose to use either tunneling or transport mode. When we use tunneling mode, everything is encapsulated, including both the packet and the header, and they're encrypted. With the transport mode, we don't worry about the header encryption. We just encrypt the data. We don't mind that you know that the other party is getting data because you won't be able to see the data. So we don't bother encrypting the header information, where it's to, where it's from, how much data, that kind of thing. But we do encrypt the data. So that's the difference in IPsec, tunneling versus transport mode. VPNs generally use a concentrator at a router that provides the VPN connections. So you would set up your router to say you need to be the VPN concentrator and you are going to handle VPN connections because you're the router that's assigned to that. We also have the ability to do dynamic multi-port VPNs, DM multi-port VPN, DM VPN, which is a secure network between multiple points. So again, you can set up a network between two different points of a VPN, set them up securely, and have a dynamic multi-port VPN. All right, for homework for this week, again, review questions, they're out there if you want to do them, the study guide questions as always, but the lab activities I'm going to choose to make optional. Not because I don't think they're important, because they are. One of them references how to do dial-up, and I do not expect any of you to actually have a dial-up modem in your home. So you can't do that lab. Some of them refer to VPNs and remote desktops, which would need a peer-to-peer computer or a way for you to VPN into somewhere. Again, if you don't have access to a VPN and if you don't have more than one computer in your home, you're going to have a hard time doing these labs. Therefore, for Chapter 14, all of the labs are optional. You don't have to do them. However, if you choose to, there will be extra credit assigned. Obviously, the StudyMate's always available, and don't forget to take the quiz. Thanks so much for watching this chapter on our remote desktop and different transmissions with telecommunications. Next chapter, Chapter 15, gets into network security. Network security is going to be a very important chapter, so make sure you're prepared for that. Have a great week. Let me know if you have any questions.